The next identity I like to talk about is x plus y times x minus y. That would be equal to x squared minus y squared. You could use it wherever you see such expression. In order to factor it, you could write it as this product, the product of their sum times their difference. For instance, factor x squared minus 1. This is of this form in which y is 1. This is x squared minus 1 squared. 1 squared is 1 also. So we write it as this: x plus 1 times x minus 1. Or (81) x squared, factor this: 81 x squared minus 25. This is also in the form of that because it's equal to 9x squared minus 5 squared. So that would be equal to 9x plus 5 times 9x minus 5. Here's another one. X squared minus y squared minus z squared minus 4y squared z squared. This is z, this is 2. Anyway, this is squared also. So how to factor that? This is in the form of this because it's equal to minus 2yz squared. So that would be x squared minus y squared minus z squared plus 2yz times, let me write the second one here, times x squared minus y squared minus z squared minus 2yz. And we just factored it, but we could also factor these two expressions also, and how deep you need to factor polynomials depends on the nature of the problem you're dealing with. So let's go further and factor the two parentheses. Let me these three are in the form of the perfect square identity. So that would be x squared minus, if you write it this way, minus y squared plus z squared plus, minus 2yz. Okay, this is equal to y minus z squared. Let me write it here. y minus z squared. And again, you could factor this one also. This is the first parenthesis here. You could factor this one also using that, and that would be, let me write it here, that would be x plus y minus z times x minus y minus z. And this is x plus y minus z times x minus y plus z. We could do the same thing for the second parenthesis. They are okay. So let us do another example, and the factor in the second parenthesis would be the same. Instead, here after we taking out the minus, that would be equal to this, and this is y plus z squared. Anyway, a to the power of 12 minus b to the power of 12 plus 2b to the power of 9a cubed minus 2a to the power of 9b cubed. Okay, this is in the form of this. How? This is a to the power of 6 squared, and this is b to the power of 6 squared, plus, again, these two having some common term. What is it? It is 2a cubed b cubed. And that would be equal to this times, and what thing after multiplying by this would be this? It is b to the power of 6. Okay, after multiplying, that would be this one, minus a to the power of 6. So this is, according to that, a to the power of 6 minus b to the power of 6 times a to the power of 6 plus b to the power of 6 plus this one. I'm not gonna write it down here. Plus this one. So these two, this one and this one, having a common expression or term, and that is this one, which here, this is the minus of that. We could write it as minus this one and multiplying by a minus. These are that. Okay, so we write it as a to the power of 6 plus b to the power of 6 times this one, a to the power of 6 plus b to the power of 6 minus this one, 2a cubed b cubed. And we could factor deeper. We could write it as a cubed minus b cubed times a cubed plus b cubed. And we could also factor this one. This is in the form of the perfect square identity. Let me erase that. So, how it is a cubed squared plus b cubed squared minus 2a squared b squared, which is a squared minus, a cubed minus b cubed squared. Anyway,